So my dear students, how are you? Namaste to all my dear students. Today I am giving you very important lecture about the oxidizing agent, reducing agent and redox reaction. And that is, if you know oxidizing agent, reducing agent and oxidation number and what you see redox reaction, you know 50% chemistry. Yes, so that is very important for knowledge as well as examination view of point. Yes, so what you see today I am talking about what you see oxidant, oxidant, reductant and redox reaction. Redox reaction. So for oxidant, reductant and redox reaction, at first we have to know what is oxidation number. So I have already told you about the oxidation number. So oxidation number, it is residual charge present in an atom in a compound. So I have already given you what to say 5 rules. Suppose we take very simple example like H2SO4. We have to find the oxidation number of sulfur. So what we have, H, you know, for hydrogen in combined state is +1, for one hydrogen, 2 hydrogens. So what we have, yes, suppose X, for one oxygen -2, for 4 how much? So -8 is equal to what is 0. So what the value of X is equal to what we have, 8, 2. So what we have, +6. I think you have clear. I have given you so many examples about the oxidation number. Yes. So in oxidant, reductant and what you see redox reaction. So in this case we have to know what happens in oxidation, reduction and what to say. So we have clear what is oxidation number. I have already told you about the oxidation number in detail with rules. Yes. Next one, always keep in mind. Yeah, we can say oxidation, reduction, oxidation and reduction in terms of oxidation number. So always keep in mind. So what to say oxidation number and reduction in terms of oxidation number. So always keep in mind. Always keep in mind. Yes, in oxidation, always keep in mind. In oxidation, generally increase in oxidation number. Oxidation number. Always keep in mind. Likewise, when you talk about the reduction, in this case, what you see always decrease in oxidation number. Yes. Likewise, when you talk about the oxidizing agent, or we can say oxidant, in this case always decrease, just reverse, decrease in oxidation number. Yes. Likewise, in reducing agent, or we can say reductant, always what is increase in increase in oxidation numbers. Always keep in mind. So these four, if you do, 4 points in oxidation, always increase in oxidation number. Reduction, always decrease in oxidation number. Oxidizing agent, just reverse of oxidation. What do you see? Decrease in oxidation number. Reducing agent is what you see, or reductant, we can say increase in oxidation. So always we have to keep these 4 points. If you know, if you use these 4 points, we have never problem to determine which one is oxidizing agent, which one is reducing agent. Yes. So at first I will talk about the what you see, talk about oxidizing agent. Oxidizing agent, or we can say, better to say reagent, that is also known as oxidant. Yes. So what you see, oxidizing agent or what you see reagent, that is also known as reagent or oxidants. So such type of reaction, yeah, we can say those, better to say, those compounds which bring about oxidation are known as oxidizing agent, or we can say simply oxidant. Yes. For example, we talk about the examples what we have. So what is Cl2, Br2, I2, nitric acid, conc sulfuric acid, what is ozone, O2, hydrogen peroxide, and acidified solution of maybe potassium permanganate, KMnO4, or we can say potassium K2 Cr27, that is potassium permanganate, that is potassium dichromate, etc. Yes. So these all are the oxidizing agent. Now we have to show how these compounds are oxidizing agent. How these compounds are, I will give you some important example like this. When you talk about the chlorine plus H2S, what we have? HCl plus sulfur. So always we have to think in left side and right side, single fight you can say. So what is Cl? What we have to see? Cl. For sulfur, what we have to see? Sulfur. Never what you see focus about the hydrogen and oxygen. So single fight you can say. So what you see chlorine in this case, we will talk about the chlorine. We are going to describe chlorine is what type of reagent it is. So what is chlorine? Sulfur, you know, sulfide -2, sulfur free atom, its oxidation number is sulfur, and arrow indicating downward shows the position of sulfur. So what we see over here? Here chlorine oxidizes hydrogen sulfide to sulfur. So it is oxidizing agents. I have already told you oxidizing. So what is chlorine? What the function of this chlorine? Increase of oxidation number from -2 to 0. Yes. So what you see in this case? Increasement in the what do you see? Oxidation number. Yes. Likewise, when you talk about first example, second example is like this. When you talk about what you see, hydrogen peroxide plus potassium iodide. So what you get? Potassium hydroxide plus Hi2. So when you see the role of hydrogen peroxide, so what do you see? Iodide has -1, I2 is diatomic molecule, so its oxidation number is 0. So what do you see? What do you observe over here? Increasement in the oxidation number from -1 to 0. So what do you see over here? Here, hydrogen peroxide increases, what do you see? Oxidizes, better to say, oxidizes potassium iodide into iodine. So it is oxidant. Yes. So what do you see? Hydrogen peroxide in this case increase the oxidation number from -1 to 0. Yes. Another example. Next example is like this. What to say? Corn sulfuric acid plus hydrogen iodide when heated. So what we have? H2O plus SO2 plus I2. So in this case, what do you see? -1. In this case, what do you see? 0. So again, what do you see? Minus increment of the oxidation number from -1 to 0. So what the role of this here? Here, conc means concentrated sulfuric acid oxidizes hydrogen iodide into iodine. So it is oxidant, or you can say oxidizing agent. So you have clear. So what the role of this sulfuric acid over here? So increases the oxidation number from -1 to what you see? 0. Yes. Last one. So what you see? Acidified solution of KMnO4. Potassium permanganate. Acidified means sulfuric acid is added over here. That is potassium permanganate. Yes, plus hydrogen sulfide. So what we see over here? Potassium sulfate, manganese sulfate plus H2O plus sulfur. So what the role of this acidified solution of potassium permanganate? What you see? It's -2, what you see? 0. So what you see? What you observe over here? So increasement of oxidation number from -2 to 0. So what you see? Acidified solution. So also we know, so manganese has what you see? +7. In this case, what you see? +2. So I'll talk about the redox reactions. So we're only talking about the oxidant. Yes. So we have clear what are the oxidant, what are the oxidizing agent. Next one is reducing agent, or we can say better reagent, that is also known as reductant. Short in examination, maybe ask you reducing agent, maybe ask you what to see? Reductants. So what are the same? Never confusion. Never confused. Yes. So what we see when we talk about the reducing agent? So those chemical substances which bring about reduction. First case oxidation, in this case about reduction, are known as reductant. Known as reductant, or we can say reducing agent. For example, what you see? Hydrogen iodide, hydrogen bromide, nitrous acid, nitrous acid, stannous chloride, carbon monoxide, ammonia, hydrogen, nascent hydrogen, etc. These all are the example of reducing agent. Now we have to know how these are the reducing agents. Suppose when we talk about hydrogen iodide and conch sulfuric acid, when heated, so what we have? H2O plus SO2 plus I2. So what the role of HI? So in this case, oxidation number of sulfur is plus 6. Oxidation number of sulfur is plus 6. But in this case, plus 4. So what you see? Decreasement in the oxidation number of plus 6 to plus 4. So here what we observe? Here hydrogen iodide reduces conch sulfuric acid to what you see? Sulfur dioxide. So it is reducing agent, or you can say, better to say, reductant. Why? Because HI decreases plus 6, oxidation number plus 6 to plus 4. Yes. So likewise, when you talk about hydrogen sulfide plus ferric chloride, so what we have? Ferrous chloride, HCl plus sulfur. So that is ferric chloride. That is ferrous chloride. So what the role of H2S? So in this case, oxidation number of iron is plus 3, but in this case, iron is plus 2. So what do you see? Reduction of oxidation number from plus 3 to plus 2. Here, hydrogen sulfide reduces ferric chloride to ferrous chloride. So it is reductant. Yes. Likewise, when you talk about carbon, when it is with conch nitric acid, so what we have? CO2 plus NO2 plus H2O. So what the role of this carbon? In this case, oxidation of nitrogen is plus 5, plus 1 X plus minus 6 is equal to 0. You know how to find the oxidation number. So in this case, what we see? Plus 5. In this case, what we see? Plus 4. So again, what we see over here? Here, carbon reduces says conc nitric acid into nitrogen dioxide, so it is reductance. We have clear. See, in oxidizing agent, always keep in mind there is increasement in the oxidation number of atoms. In reducing agent, always what you see? Decreasement in the oxidation numbers. You have clear what are the oxidant, what are the reductant. Yes, but now next one is very important, that is redox reaction. That is redox reaction. So red means, always keep in mind, red means reduction. Ox means oxidation. Yes. So never talk red means rato and what you see ox means guru. So I say red means reduction, ox means oxidation. So we are talking about the oxidizing and reducing agent. So only explain about the oxidizing agent and only explain the what is a reducing agent. But always keep in mind, where there is oxidation, there is reduction. Where there is reduction, there is oxidation. It means oxidation reduction takes place simultaneously or side by side, or you can say hand by hand. So what you see when we talk about the redox reaction, so what you see, such type of reaction in which oxidation and reduction takes place simultaneously, or we can say side by side, or we can say hand by hand, is known as redox reaction. Redox reaction. So we take very simple example. We take simple example like H2S plus ferric chloride. So what we have? Ferrous chloride, HCl plus sulfur. So what the role of H2S? Plus 3 to what do you see? Plus 2. So what do you see over here? Reduction. That process is known as reduction. And itself, this ferric chloride itself oxidized from -2 to 0. So what do you see? In this case, what do you see? Oxidation. Yes. So what do you see over here? In this case, what do you see over here? कि hydrogen sulfide reduces ferric chloride to ferrous chloride itself oxidizes from hydrogen sulfide to sulfur. Likewise, when you talk about the ferric chloride, what do we observe over here? Ferric oxidizes hydrogen sulfide to sulfur and itself oxidizes, itself reduced from ferric chloride to ferrous chloride. It means oxidation and reduction takes place simultaneously, or you can say side by side, we can say what you see, hand by. So how we have to write in examination? Here hydrogen sulfide reduces ferric chloride to ferrous chloride. So it is a reductant, reducing agent, but itself oxidizes from hydrogen sulfide to sulfur. Yes, that is the half. Next one is when we talk about the ferric chloride. Similarly, what is the ferric chloride? Ferric chloride oxidizes hydrogen sulfide to sulfur, and itself reduced from ferric chloride to ferrous chloride. It means oxidation and reduction takes place simultaneously. So it is the example of redox reaction. So I think you have clear. So in this case, one compound oxidizes other and itself reduces. One compound reduces other and itself oxidizes. So both oxidation reduction takes place simultaneously. Yes. So that reaction is known as redox reaction. Second example, when we talk about the stannous chloride plus mercury chloride, that is stannous chloride, and that is the mercury chloride. So what we have? Hg2Cl2, that is mercurous chloride plus HCl4, that is known as stannic chloride. So what do we see over here? When we talk about what you see stannous chloride, so what do you see? +2, what do you see? +1. So reduction. Here what do you see? Reduction. Yes. And when it reduces mercury chloride to mercurous or itself, that is +2, it has what you see? +4. How many chlorine? 2 chlorine. In this case, how many chlorine? 4 chlorine. So the oxidation number of SN is +2 over here, but in this case +4. So what you see over here? That is oxidation. Yes. So what do you see here? Stannous chloride. Yes, stannous chloride reduces mercury chloride to mercurous chloride. So it is reductant. Why? Decreases over here. Reductant and itself get oxidized from stannous chloride to stannic chloride. So what do you see? Increasement. Yes. Likewise, Likewise, when mercury chloride oxidizes, mercury chloride oxidizes, yes, oxidizes stannous chloride to stannic chloride. So, it is oxidant and itself get reduced from mercury chloride to mercurous chloride. It means oxidation and reduction takes place simultaneously. It is the example of redox reaction. Yes. Second example. Now, third example is like this. What to say? Nitrous acid plus iodine plus H2O. What we have? Hi plus HNO3. So that is nitrous acid. Iodine, you know, hydrogen iodide, and that is nitric acid. So what do you see over here? This, when we talk about the nitrous acid, I2 has 0, iodide has -1. So what do you see? So that is the reduction. Yes, and in this case, nitrogen has how many? 4 minus 1. What is it? Plus 3. In this case, oxidation number of nitrogen is plus 5. So what to see? What you see over here? That is the oxidation. Yes. So we'll talk about the language in examination. So what we write over here? Here, nitrous acid reduces iodine to hydrogen iodide. So it is reductant, but itself get oxidized from nitrous acid to nitric acid. Yes. Likewise, what is iodine oxidizes nitrous acid into nitric acid. So it is oxidant and itself get reduced from what to see iodine to hydrogen iodide. So oxidation and reduction takes place simultaneously. Know how to write in examination? Yes. Fourth example is like this. Fourth example. So what is see KOH plus bromine. So what we have? KBr plus KBrO3, that is potassium bromate plus water, that is potassium bromide. So what we have? So in this case, what we see? Bromine. So in this case, bromine has 0, but in this case -1. So what do you see? Reduction. In this case 0, but in this case how many? +5. So what do you see? That there is oxidation. So in this reaction, what do you see? Bromine acts as both oxidizing as well as reducing agent. In this reaction, bromine is what to say reduced into potassium bromide and oxidized into what to say potassium bromate. So in this, so what the role of this bromine over here? It acts as both. It means here bromine acts as oxidant as well as reductant. So I have already told you about what are the oxidant, what are the reductant, what are the redox reaction. So many example I have given you. So I think you have clear. So thank you for watching this interesting video, and hope you have already subscribed about this channel and also convey this channel to your friends for learning. So have a nice day.